We recall this scenario in which there are these many people, and we have a statement that at least two of these guys have same birth month, and we create a situation of bet where the amount to be won, if the statement is right, is $3,000, but to take this bet you have to pay $400. To decide whether we should take this bet or not, we have to look into the probability of our winning, and if that is quite high, then accordingly we will decide what is the cost at which we can take the bet. So first most important point becomes that what is the probability that we will win this bet. Now in this case, as we know that there are 13 persons, and since we have only 12 months in a year, so if all the 13 persons have to have different birth months, then that is not possible because only 12 months are there. So it is sure that at least two persons will have same birth month, and this statement that at least two of these guys have same birth month, that will be true, and we will win the bet whatever the scenario is. So here the probability of winning the bet is 1, and so whatever is the amount which we have to pay to take this bet, that is all right, we should go ahead and we will be winning this bet. But now if the number of persons is reduced from 13 to 12 or to 11 or 10, as the number of persons reduces, the probability of winning the bet also will come down. So let us evaluate in this video if the number of persons is exactly 6, which is half of the number of months available, then in that case what is the probability of winning the bet? Intuitively, if we try to think, then since there are 12 months and 6 persons are there, and if you think that the probability of winning the bet will be 6 by 12 or something like 0.5, then that is completely wrong logic. And if we evaluate what is the probability of winning, whether it is more than 0.5 or less than 0.5, or how much more or less than 0.5, then we get some very interesting idea about the risk and our understanding, rather intuitive understanding of the risk. So let us do the calculation. 6 persons can have birth months in 12 into 12 into 12 into 12 into 12 into 12 ways. Since there are 12 months, so first person can have birth month in any of those 12 months, and for every such answer the second person too will have any of the 12 months, and for each combination of these two birth months the third person also can have any of the 12 months. So that way if we continue, we find that the 6 persons can have their birth months in these many ways, which is 12 multiplied 6 times. Now to find out the probability that at least 2 are having same birth month, we can find the number of ways in which exactly 2 are having same birth month, then exactly 3 are having same birth month, then exactly 4, 5 and 6 are having same birth month. So that gives us the number of ways. If we sum all these possibilities, then that will be giving us the number of ways in which at least 2 persons are having same birth month. That number divided by 12 to the power 6 will give us the probability that at least 2 persons are having same birth month. But that process is quite lengthy, and we also want to build such kind of method using which we can find the probability of at least 2 persons having same birth month from different number of persons ranging from 2 to 13. So let us have a better logic here, that we find the number of ways in which all are having different birth months. So in that case we will be losing the bet. We will find the probability that we lose the bet, and then 1 minus this probability will be giving us the probability of winning the bet. It means first we will be finding out the number of ways in which all are having different birth months. Then that divided by this number will give us the probability that all are having different birth months. So if we subtract that probability from 1, then that will give us the probability that all are not having different birth months. It means that at least 2 are having same birth month. So let us find that number of ways in which all are having different birth months. They will have different birth months in 12 into 11 into 10 into 9 into 8 into 7 ways. First person can have any of the 12 months as his birth month. The second person, if he takes the first person's birth month as his birth month too, then at least 2 are now having same birth month, so the condition gets satisfied there itself. So to have the condition not satisfied, that is they having different birth months, the second person birth month can be any of the 11 months remaining after excluding the first person's birth month. Now for the third person, the first two persons birth month should not be considered. So third person will now have only 10 months to have all the 3 different birth months. So that way if we continue, then the number of ways in which all these 6 persons are having different birth months, that is 12 into 11 into 10 into 9 into 8 into 7. So the probability that all are having different birth months will be 12 into 11 into 10 into 9 into 8 into 7 divided by 12 to the power 6, which is equal to 0.223. So the probability of losing the bet, that is all are having different birth months, that is 0.223. So if we subtract this from 1, that will give us the probability of winning the bet, and that is 0.777, which is quite higher than 0.5. So even when 6 persons are there, then probability that at least 2 are having same birth month, that becomes 0.777, and that gives us the probability of winning. If we work with a feeling that the probability of winning is 0.5 because there are 6 persons and 12 months, so this understanding will make us behave in a very conservative way. And if we understand that the probability of winning is 0.77, which is much higher than 0.5, then accordingly we can manage the risk in somewhat more aggressive way. So understanding of the probability will help us in managing the risk better.